Okay, so the point of this video is to try to get your data off the Garmin watch and into a format that's easier to look at and play around with. So if you go to the Garmin Connect website like this, I have a Garmin watch that I use for running, and it tracks your GPS position, heart rate, speed, elevation, that kind of stuff. And then it puts it all automatically onto here. So you can go into like all activities here and then basically just pick one, and it automatically populates all this stuff, which is pretty cool. It shows your path, and then it shows these graphs with the elevation, pace and stuff, heart rate. So for me, what I care about is the heart rate, and I'm always trying to target a certain heart rate and cadence, actually, also cadence right here, steps per minute. But when you look at these, it's really hard to see any fine detail the way they plot these graphs, right? So the way they scale the axis, and like why is this whole thing filled in red, and all that kind of stuff. So I'd really like to be able to download it into like a spreadsheet and work with it on Excel or Jump or in Python. So so that's the point, and basically by the end we're going to have something that looks like this, and I have to use Python to get it into this format, and I'll show how to do that. But basically this is what we want, all the same information here, but in a spreadsheet format. And then also, you know, there's some kind of manipulation you can do to the numbers. Like for example, I did this smoothing and converted from meters to miles and that kind of thing. Okay, yeah, let me cut in here for 1 second and just say, if all you care about is converting your file from TCX to CSV, and then you can take it from there, all you have to do is download this file from the GitHub, change your file name right here, go to the very last one, change your output file right here to whatever you want it to be, and then run the whole thing. Hit run all right here, and then it should work. You know, assuming you have the same, let's see, the same watch as me. I have the Phoenix 5. I don't know if it would work when there are other data types involved. Like if your watch doesn't have heart rate, it will probably throw an error here, and you'll have to go in and fix it. But I'll explain how to do it. So you can do all that in Python, but basically here's how you do it. First, you have to download this file. So what you do, once you've found the one that you want, you click on here, and then you do export TCX. So there's two types of formats. This will work too, but it's a little bit different, and I don't think it includes the heart rate data. I think it's just the location. So I use the TCX one. I downloaded it to my computer. It comes out with in a format that looks like, let's see, this. Like this one, activity some number.tcx, and it looks like an XML file where it has these tags, and then like these nested tags and stuff. So training center database, activities, activity equals running, ID, lap. So basically the way this looks when you download it, it has laps, and by default, like 1 lap is 1 mile. If you don't mess with it on your watch. So each lap has like a total time, distance is in meters, but it's 1 mile. Your speed, calories. So this is like the summary by laps. And then if you go deeper into this track and track point things, every second it saves 1 track point. So 1 track point per second. And that's where all the really detailed information goes in. So each track point has a time, a position, altitude, distance, heart rate, all this kind of stuff, cadence. So this is what I want to plot but in this format right here, I can't really do anything with it, so I have to first convert it to that spreadsheet type format, and I'm going to use Pandas, so it will be not a spreadsheet but a data frame with all these in XML they're called tags, but they'll just be column labels in the data frame. So here's how we do it. All the imports, the file name, just copied it in there. So let me restart this, and then we can step through it. So that first thing you do is with this element tree library, you parse it into a tree. Root is the highest level thing, so that's the I believe it's called let's see, it's called activity, or it's called this training center database, and then activities and author are the first level. So you can kind of cycle through 4x and root, tells you all the children of that. And then one way to do it, so since you did this, you have 2 children, so now you can go into the activities and then do it again for x in root index 0. What's inside activities? It's just 1, and that we can see right here, the activity. I just did 1 activity, and then what's inside that is all the laps. So there's an ID tag, and then there's all the laps, and then there's the creator tag. So basically you can like dig down here by using these index numbers. So if we go to index number 1, that will be the first lap. And then another thing you can do is print child.tag or child.text. And so that gives you what's inside the first lap. So if we go back to the document, so the first lap has time in seconds, distance in meters, maximum speed, all that kind of stuff. So you can print it out here. Total time in seconds, distance in meters, etc., all the way down. So that's how you read it. And then for heart rate, you can see like it's kind of ridiculous after a while doing this kind of thing, like root 00140 to get all the way down the tree to just to retrieve one of the heart rate values. So you would have to do this like for every single track point once a second to build your data frame. So it's that way is good for looking up stuff when you're first loading a file, but if you want to do anything interesting, you probably have to use these other methods. So you can do this run dot, okay, so I said run is my run activity, which gets rid of 2 of those zeros, but basically you can do this find all function and then put in the tag name that you're looking for, which is like find anything with this lap tag in it. So it found 8 laps. And then once you're inside those laps, you can go iterate through all the track points, right? So this is finds all the laps, looping through all the laps, and then you know, for actually this is just in lap 8. It's just going to go through and print out tag and text for all the track points in that lap. So that's like one way. It's super long, but that would eventually print out all the info that you need. So one thing you can do to shortcut it is the namespaces. So these super long names right here, you can rename them as these NS, NS2, and S3 things, so that once you have this namespace dictionary saved, instead of referring to it like this, you can just refer to it like this. So that's just a nice shortcut to make it easier to read. Okay, next we went through for all the laps. So we're iterating through all the laps, and then we're going to print out lap.find, track point, heart rate. And so basically what I'm showing here is instead of using find all, so you can use find all to give you a return a list of all the laps. You can just do find, and that will return the first thing that matches this tag. So when I do lap.find track and then .find track point, it's only returning the very first track point on that lap. So here we have one heart rate value for each lap, which is just the first one that it found. Okay, so that's basically how you navigate through the XML file. Now for this one, how do you make it into a Pandas data frame? Iterate through all the laps, and then within each lap, I want to iterate through each track point. So now I'm using find all track points, right? Okay, and then I made a dictionary, a new dictionary for each track point, and it's going to have these keys, and then these are the values. And right here you can do some kind of processing to them if you don't like the format that they're in. Like for example, I rounded off some of these numbers because like altitude in meters, it by default has like a huge long decimal at the end that is not very meaningful to me, so I just rounded it off. This is also where you have to set the data type here because otherwise it will just be a string by default. So some of them I changed to floats, or instead, and also the time I did this datetime .parse. So this is one of the libraries that I imported, and I didn't really explain how this works, but it just basically gives you the date in a datetime variable instead of in a string variable. What else? There was a trick with the cadence. For some reason, the cadence that the watch tells you is basically half of what most people consider the cadence. So it would be basically like how many right footsteps you took is that number. So I just multiplied it by 2 here. And you could convert like these things, distance and elevation, to feet or miles here if you wanted to. I ended up doing it later. And then the lap number comes from this enumerate, so that gets added on there. And then I have this data list, which is just a list of dictionaries. So now I've got a list of dictionaries where it has one dictionary called data for each track point. And instead of being broken down by laps, now it just has lap as one of the columns, right? So then you can just load the whole thing into a DataFrame, Pandas DataFrame like this, and this is how it looks. So time, latitude, longitude, etc. All this stuff, and there's the lap right there. Cool. So that was like, for me, that was like the hardest part, is like, how do you get it from XML to Pandas? This is the first time I've ever done it, and I didn't find very many helpful tutorials online about how to do that. So this is one example. It's actually, once you've done it once, it's not that hard, but it took me a while. So here's an example of how to do it specifically for this Garmin TCX file format. So what you can do once you have that, you can do something like this, where you can plot the longitude and latitude. So it looks kind of like what you saw on the website. Let's see, over here. So it's basically this thing without the map. So we can do that pretty easily. And then, you know, if you wanted to do the color, right, the color map where it shows, I believe this one uses speed. Yes. So it uses speed as the color map. You could do that. I like to look at it with heart rate. So here's heart rate, but you could put in speed. What is it? Is it just speed? Speed. So yeah. Let's see, speed. Do it that way. But I like it with heart rate. So you can do that, and then you can also, you know, I was messing around with some stuff here, you can change the size of the markers also, to have another dimension of data in here if you want to. Oh, I made a note for myself to draw it on the map. I don't know how to do this yet, but that would be a cool thing to add, so you can see it on the map. Yeah, so this lets you do all those features, and I know on Strava, this feature, like doing the color map, is a paid feature, but you can do this with one line of code once you have downloaded it onto your own computer, so that's pretty cool. And then for heart rate, so I can plot the heart rate, and the reason why I didn't like the heart rate plot, the reason why I didn't like the heart rate plot over here, remember, is like, I don't know why it needs to be filled, and it's super small, like I don't like the scaling of the axis, and it's hard to see any fine detail in here. I can see like in the big picture, it was like it comes up and then it goes down a little bit, and then it comes up and goes flat for a while. And I actually don't like how this thing follows my cursor everywhere. It's kind of annoying. It looks cool at first, but then when you're trying to like point stuff out, it gets annoying. So anyway, so here's a quick way to plot heart rate. You just say plt.plot and then the variable. That's the quickest way. And then yeah, here I can set the limit, y limits, set the label, there it is. So this, instead of having 125, I can set it to whatever I want, because I don't necessarily care about way down there at the beginning. I care about like the later on time. So maybe I would even want to go like 150 here and then see a little bit more detail. Yeah, this is kind of messy. So the first thing that I did was put in a new column in the data frame called heart rate smooth, which is a rolling average using the last 20 steps. So luckily this, I just found this out today also, this is also a built-in function where it will just average the last 20 things automatically. So that smooths out the spikes, so you can see the difference between this guy and this guy. This one looks a little bit cleaner, and like, yeah, if we're being honest, your heart rate shouldn't be spiking this much. That's probably just noise in the sensor. The way it measures is maybe not so great. So so this looks a little bit cleaner. What else? Okay, so the next one after that, after that, I wanted to put on the x-axis, instead of having just arbitrary point numbers, these are just the track point number, I wanted to put miles, and that's pretty simple when you do scatter plot on matplotlib. It goes x, y for some reason, so this is the x, and then this is the y. So that's super simple to do also. S means marker size. Oh yeah, and also I converted my distance to distance in miles. Yep, and I used the smooth one again. Rescaled the axis, labeled. And then the next thing that I tried to do is to set the color map. So this is another super easy to use feature in matplotlib. You just do C equals whatever whatever column you want to follow on the color map. So I use the elevation. You know, you might think that, oh, okay, well, if the elevation is going up, then your heart rate might go up, and you might see some kind of correlation there. So, you know, it did a little bit right here. Something interesting was happening right here. I guess this was, so when you see a darker thing, that means the elevation's higher. So I was going uphill, but my heart rate was staying pretty much the same in that region. So in this one, it was a really big spike on heart rate, and then interestingly, the elevation kind of went up at the tip, and then the heart rate dropped. So maybe not what I expected, but at least you can see this, visualize this kind of stuff. And then, so I was thinking, okay, well, I don't actually care about the absolute elevation. I care about the change in elevation, right? Like, I want to know if you're moving uphill, then that's when your heart rate should probably spike, right? So if you're traveling uphill, this one would show just the total height. So you could be moving on a flat path, like once you get up to the high point, you could be going flat, and that would show still a very high elevation, if that makes sense. So I think this is a more logical way to do it. And this, another thing that I just learned today, this diff function is built into Pandas. So this just gives you the change from the previous row to the current row, which, you know, with a arbitrary change in time, which is just 1 second, you can kind of approximate the derivative, right? So for this D elevation column, it's the change in elevation from the previous track point to the current one. And then we can see like a darker color here would be moving uphill, and then a lighter color would be moving downhill. But it turns out that in this particular run, there wasn't really I wouldn't say there's an obvious correlation between going uphill and increasing heart rate. So yeah, that's an interesting thing that you can see. And then I went ahead and swapped heart rate and elevation. So now elevation is on the y-axis, and then heart rate is on the color map. Again, not any clear correlation, but it makes it a lot easier to look at for me than this thing where I'm looking at heart rate in red here, and then I guess elevation. Because of the way they scale the elevation from 0 to 700, you can't actually see anything on the plot. It looks pretty flat on the plot, which, you know, it was a pretty flat run, but I'd at least like to see the the changes. This pace thing also, you could use pace. You'd have to convert it because they, in the program or in the output of the watch, it just gives you distance. And actually, I think it gives you speed also. So you could either do the difference in the distance like I just showed, or you could look at the speed tag and then take, you know, invert it. So speed is like miles per hour, pace is minutes per mile. So that's a pretty simple calculation to do if you cared about seeing this. Personally, I'm not super worried about the pace. I'm just trying to maintain a constant heart rate when I run. So so that was important for me, and I'm trying to maintain like a higher run cadence if I can. So I'm curious about like how do I increase my run cadence without increasing my heart rate too much? Because it's like once you start stepping faster, it's hard to keep the heart rate down. So that's what I'm looking at. And then, oh yeah, I made a note. I should also do a plot correlation matrix. So what you what the next thing that I would do if I was like really analyzing the data is look at the correlations between all of these columns, right? So we have the columns which are, let's see, here. You know, we looked at elevation versus heart rate. We looked at, did we look at speed versus heart rate? That would be another one to look at. I don't think we did. No, we looked at distance versus heart rate, right? Which, you know, that one often correlates well because the first 2 miles your heart rate is kind of slowly creeping up, and then maybe it flattens out a little bit. Maybe it does some interesting stuff after 4 miles. I'm not really sure why. So this, now that I can see it a little bit more clearly, this is pretty cool to me. Is like, why did it level off for so long and then spike up like that? Not really sure. But yeah, we could look at, you know, so basically the correlation matrix would be showing correlations between all of these different features, which I think you could probably just do it in here too. If this is more comfortable for you. Insert chart. Right, so here is speed and here is heart rate. So yeah, I don't know, I like Matplotlib better. Where is this? So you should be able to draw like a best fit line through here, right? Trend line. There we go. Why does it take? So it takes a few clicks, but you can eventually get something like this and see that, okay, yeah, my speed and heart rate both go up, you know, in general. Not always, because sometimes you have a very high heart rate and low speed for some reason right here. You know, that could be going up a hill. Yeah, so you could show R squared. Yeah, so this is one way you could look at it. You can do all the same thing in Python as well. So I like to use the Jupyter notebook because it has more flexibility once you know. Like a lot of times it's annoying to have to go look up what all the functions are, but a lot of them are already built in, so super nice. And oh yeah, and the last thing is, how do you get this file out? It's just like this, super simple. You designate the file name and then you just say df2 CSV out file, and then you can put that on your Google Drive to look at it in Google Sheets like this, or look at it in Excel or Jump or whatever. It's already in a good format to use in those kinds of programs. So that's it for how to get data from Garmin device to spreadsheet format. Awesome.